Welcome! CSEC Chemistry, January 2023, Paper 2, Questions 1 to 3. Subscribe and share for other upcoming content. Let's begin. Question 1. A. Students were required to prepare a sample of the normal salt produced when aqueous sodium hydroxide reacts with dilute sulfuric acid. Part 1. Define the term normal salt. Normal salt is a salt formed when a metal or a group of elements acting like a metal completely, I repeat, completely replaces the hydrogen atoms in an acid molecule. Part 2. Identify one other type of salt that can be formed from the reaction between dilute sulfuric acid and aqueous sodium hydroxide. Another type of salt that can be formed is acid salt. B. The normal salt was produced by conducting a titration. The students were provided with sulfuric acid, sodium hydroxide, and methyl orange indicator. The procedure is outlined in parts A and B. Here are the burette readings for the titration. Part 1. Complete Table 1 by using the readings shown in Figure 1 on page 6. Back to page 6. We will be measuring the volume for each burette reading. So this is 0. Each interval represents 1. So this would be 0.1, 0.2, 0.3, 0.4, 0.5. So this initial reading is 0.50 cm cube. So now we're going to read the final. So here we have 25, 25.1, 25.2, 25.3, 25.4, 25.5. So 25.5 cm cube. Titration 2, initial. Here we have 12, 12.1, 12.2. So the initial reading 12.20 cm cube. The final reading, so this is 37, 37.1, 37.2, 37.3. So 37.3 cm cube. Titration 3. So we have 15, 15.1, 15.2, 15.3, 15.4, 15.5. So 15.50 cm cube. The final reading for titration 3, 40, 40.1, 40.2, 40.3, 40.4, 40.5. 40.50 cm cube. We are going to place all readings in the table to 2 decimal places. We are going to find the volume of acid used for each titration by finding the difference between the final reading and the initial reading. Therefore, for titration number 1, the volume of acid used will be 25.50 cm cube minus 0.50 cm cube, and this equals to 25.00 cm cube. Titration number 2, the answer will be 12 25.10 cm cube, and the titration 3 will be 25.00 cm cube. Part 2. In Table 1, indicate using asterisks the titration volumes that will be used to calculate the average volume of sulfuric acid. The volume of acid in titration 1 and 3 will be used, so we place an asterisk beside the numbers. Part 3. Calculate the average volume of sulfuric acid used in the titration. To calculate the average volume, we will be adding the volume of acid used in titration 1 and 3, after which we are going to divide it by 2. The average volume of sulfuric acid equals 25.00 cm cube. Part 4. Complete the procedure for Part B by stating the steps required to obtain a dry sample of the normal salt. Here's the Part B procedure. Number 1. Pipette 25 cm cube of the sodium hydroxide solution and transfer the solution to a conical flask. Step 2. Using the burette, add the volume of sulfuric acid used to neutralize the base from Part A to the sodium hydroxide solution in the conical flask. Step 3 would be pour the solution into a beaker, gently heat the solution over a Bunsen burner to evaporate 1/3 of the liquid. Step 4. Pour the solution into an evaporating dish. Leave undisturbed on a bench top to cool. Evaporation will continue and sodium crystals will form after some time. Part 5. Write a balanced equation including state symbols for the formation of the normal salt from sulfuric acid and sodium hydroxide. The equation will be sulfuric acid H2SO4 aqueous plus sodium hydroxide NaOH aqueous to produce sodium sulfate Na2SO4 aqueous plus water liquid. This equation isn't balanced since there is 1 sodium on the reactant side and 2 sodiums on the product side. Also, there are 3 hydrogens on the reactant side while 2 hydrogens on the product side. In order to balance this equation, we will be writing the numeral or coefficient 2 in front of the sodium hydroxide on the reactant side and 2 in front of the water molecule. Part 6. Calculate the number of moles of sulfuric acid used to neutralize the sodium hydroxide. Molar mass for sulfuric acid is 98 grams per mole, and for sodium hydroxide, 40 grams per mole. In order to calculate the number of moles of sulfuric acid used, we have to know the mass of sulfuric acid. Mass of sulfuric acid equals concentration multiplied by volume. Based on the experiment, the concentration of sulfuric acid is 4.9 grams per dm cube. The volume is 25 cm cube. Now for this equation, we have to convert the cm cube to dm cube. Therefore, 25 cm cube equals 0.025 dm cube. 4.9 grams per dm cube multiplied by 0.025 dm cube equals 0.1225 grams. This mass will be used to calculate moles. Moles equal mass divided by molar mass. 0.1225 gram divided by 98 grams per mole equals 0.00125 moles of sulfuric acid. Part 7. Calculate the mass of the normal salt expected from the reaction. The RAM for sodium is 23, oxygen 16, sulfur 32. Based on the balance equation, the mole ratio for sulfuric acid and sodium sulfate is 1:1. The mole of sulfuric acid and sodium hydroxide will be the same. Hence, there will be 0.00125 mole of sodium sulfate. Now we need to calculate the relative atomic mass. In order to do that, we are going to add the mass of all the atoms that make up a molecule of sodium sulfate. Hence, sodium mass is 23, and since there are 2 sodiums, we multiply that by 2, plus the mass of sulfur 32, plus the mass of oxygen 16, and since there are 4 in the molecule, we multiply that by 4. This equals to 142 grams per mole of sodium sulfate. 1 mole of sodium sulfate is 142 grams. So 0.00125 mole equals X. We are going to cross multiply in order to find this mass. X equals 142 grams multiplied by 0.00125 moles. The answer is 0.178 grams of normal salt. Part 8. The actual mass of salt obtained by the student was 0.09 gram. Suggest one possible reason for the difference in the expected mass of the salt and the mass obtained. A reason is loss of mass during transfer of salt from one container to another, or impurities in the reagents. Question 2. One of the main active ingredients in chlorine bleach is the oxidizing agent, sodium hypochlorite. By adding sodium hypochlorite to water, hypochlorous acid is formed, according to the equation below. A. State one use of bleach in the laundering of clothes. Bleach is used to whiten clothes, or it is used to remove stains. B. Define each of the following terms. Part 1. Oxidizing agent. Oxidizing agent is a substance that gains electrons in order to oxidize other substances in a redox reaction. Part 2. Oxidation. Oxidation is the loss of electrons by an atom, ion, or molecule. C. Deduce the oxidation number of chlorine in the formula NaClO. We will be using the oxidation rules. Sodium has an oxidation number of +1, chlorine X. Oxygen has an oxidation number of -2. This compound equals 0 in oxidation number. 1 plus the unknown X minus 2 equals 0. Now I will be placing the numbers together. So X plus 1 minus 2 equals 0. 1 minus 2 equals -1. Therefore, X minus 1 equals 0. Place the -1 over the equal sign, and this will change it to +1. Therefore, X equals +1. So chlorine oxidation number is +1. D. Chlorine gas also reacts with water to form hypochlorous acid, as shown in the equation below, and in which the chlorine gas has become a chloride ion. Part 1. What is the change in oxidation number of chlorine for the process? Chlorine gas converts to chlorine ion. In this equation, chlorine gas is a compound having the oxidation number 0. Chlorine ion has an oxidation number of -1. Chlorine gas to hypochlorous acid. Now the chlorine gas oxidation number is 0, while in the hypochlorous acid, chlorine is +1. We get +1 because hydrogen is negative. It is +1 because hydrogen has a +1 oxidation number, oxygen has a -2, and the compound must equate to 0. Therefore, chlorine will be +1 in hypochlorous acid. Part 2. Which process occurred when the chlorine gas became a chlorine ion? Since there is a decrease in oxidation number from 0 to -1, this is reduction. Part 3. Describe a simple laboratory test for chlorine gas. Using damp blue litmus paper test. Place a damp blue litmus paper in the presence of the gas. Chlorine gas will change the color from blue to red, then to white. E. A more natural alternative to chlorine bleach is the use of detergents which release hydrogen peroxide in water. Here is the equation, and based on the equation, show the changes in the oxidation number for oxygen in hydrogen peroxide aqueous and water liquid, and deduce whether this is an oxidation or reduction reaction. Hydrogen peroxide will have an oxidation number of 0 since it is a compound. For hydrogen, the oxidation number is +1. Since there are 2, we multiply it by 2. Plus the oxidation number for oxygen X multiply by 2 since there are 2 oxygen in the compound. 2x equals -2. Therefore, the oxidation number of oxygen in hydrogen peroxide is -1. The oxidation number for water molecule is 0. To find the oxidation number for oxygen, hydrogen plus 1, since there are 2, multiply by 2, plus the unknown x. 2 plus x equals 0. We are going to carry the numeral 2 over the equation sign. Therefore, oxidation number of oxygen in water is -2. This is a reduction reaction since there is a decrease in oxidation number. Question 3. A. Cracking is a very important process in the petroleum industry. What is meant by the term cracking? Cracking is the process where complex organic molecules or long-chain hydrocarbons are broken down into simpler molecules or light hydrocarbons. B. Compound A, C4H8, and the compound B, C4H10, are both hydrocarbons that can be obtained from cracking. Part 1. State the names of compound A and compound B. Compound A have the chemical formula CnH2n. Therefore, it is an alkene. Since there are 4 carbons, the prefix is bute. So compound A is butene. Compound B has the general formula CnH2n plus 2. Therefore, it is an alkane. Since there are 4 carbons, the compound B would be butane. Part 2. Draw fully displayed structure of compound A. You should draw the molecule showing all the bonds. Here is compound A having 2 double bonds, 4 carbons and 8 hydrogens. Part 3. State the homologous series to which compound B belongs. Answer: alkane. Part 4. Describe briefly one test that could be used to distinguish between compound A and compound B. Write the expected observations. The test will be bromine water test. Mix bromine water having an orange color in separate containers for compound A and compound B. Observations. The alkane butane will have no color change with the bromine water, so the mixture remains orange. However, for the alkene butene, the orange color of bromine water will change to colorless. C. Compound B, C4H10, can exist as structural isomers. Part 1. Define the term structural isomers. Structural isomers are compounds that have the same molecular formula, same number and types of atoms, but different chemical structures, which is different arrangement of the atoms. Part 2. In the space provided below, draw fully displayed structures of 2 isomers of compound B. you must draw the structure showing all bonds between atoms. Isomer 1 can be a chemical structure with 3 carbons in the longest chain, having one attached methyl group on carbon number 2. Isomer 2 could be a straight chain with 4 carbons and 10 hydrogens. D. Compound A burns in oxygen with a sooty flame. Write a balanced chemical equation for the complete combustion of compound A in excess oxygen. Butene C4H8 gaseous state plus oxygen gas O2 produce carbon dioxide gaseous state CO2 plus water H2O liquid. This equation is not balanced since there are 4 carbons on the reactant side while 1 carbon on the product side. Also, there are 8 hydrogens on the reactant side while 2 hydrogens on the product side. There are 2 oxygens on the reactant side while 3 oxygens on the product side. In order to balance this equation, we are going to write the coefficient or numeral 6 in front of the oxygen gas, 4 in front of the carbon dioxide, and 4 in front of the water molecule. This is the end of question 3. Questions 4 to 6 solutions will be posted. Like, share, and subscribe for other upcoming content. Thanks for watching. All the best.